math, one of your colleagues asked this question. So we were given the marginal cost. So why I'm doing this? Because it pertains to what we are looking here. So this is, first of all, a definite integral and approximating. So these two elements are right already in here. So we were given a marginal cost. We're asked to find the total cost during the first 280 days. So all we have to do for exact value, find the definite integral as we always do. But what if the same problem says also estimate the cost? That's fine. You have the exact value and you determine the number. That's awesome. And don't forget the measurement unit. It has to be in dollars. This is dollars per day. I'm not sure if X was days, but I'm assuming it was. And this will be in dollars. But what if I'm adding this to our problem? What if we are given the same interval? We are asked to use 4 subintervals to approximate using the leftmost point. So for the leftmost point, I have to find C prime of 0, C prime of 70. So first of all, I divided this into 4 equal parts. 280 minus 0 is 280, divided by 4 is 70. 70, 70, 70, 70. So then the base is 70, that's why I pulled it out, times C prime of 0 plus C prime of 70, C prime of 140, and C prime of 210. If you go to C prime of 280, there will be a tragedy because we have 4 subintervals and we already have them. 1, 2, 3, 4. You cannot add 280. Okay? 1, 2, 3, 4. C prime of 0 is the height, the first one, the 70, and 140, and 210. You will calculate these, add them up, multiply by 70, and you get a number. Of course, this is not going to be the same. This could be an underestimated of the exact, underestimation, or over. Okay, so this was the first question that I wanted to go over because we just talked about it half an hour ago. Before you ask any questions, so this basically deals with finding a definite integral. We just talked about that. And also approximate. So these two already had at least one example so far. Now, so let me just quickly read this and then I will start with your questions. Indefinite integrals, we can choose. That was section 4.4, 4.5, the entire chapter 4. The total area, right? So this is the same thing. So this is also, we determined the total cost, but we can be asked to find the total area or the total revenue or the total profit or the total cost or the total sales or the total time or the total whatever. And one thing I forgot to add here, average value of a function on an interval. Okay. So this is the same thing. So this number 3 is the same thing. In this problem, we were asked to find the total cost. Okay. So antiderivatives, of course, if we don't find the antiderivative, if we do not find the antiderivative of this, we cannot find the exact the exact cost. So this, which function prime is x? Well, it's x squared over 2 and 8.25x. So this is the antiderivative. Since it's a definite integral, we evaluate it from 0 to 280. So this is the antiderivatives. Areas enclosed by graphs. Adding definite integrals, remember the integral from a to c f of x dx can be written as the integral from a to b plus the integral from b to c. That's what the adding formula is. Consumer surplus plus producer surplus. Differential equations. The linear regression line with TI-84, so this is, I hope, very clear. And the several variables, functions with several variables to evaluate, to find partial derivatives, and find max min with a d-test. And then the average value of a function, remember the formula, is f average, 1 over b minus a, the integral from a to b from f of x dx. Okay, so let's start with your, oops, I didn't realize that I was kind of skewed there, sorry. So what would you like to continue with? Any questions you may have? Anything you want to start with?
Can you go over homework question 22 from?
Yes, any question, yes. So you said 22, and
Yeah,
this was
576. I mean 576. Yeah.
yes. Okay. So I have the book right here, and you said 576, and you said number 20, the maximizing profit. No,
22.
no, 22. Sorry. You said 22. Okay, yes, very good. So, oh, I see the function. Let me copy it. P of a comma p. I don't like this. So this is not really a good notation. Plus 80p minus 15p squared, and minus 1 over 10a squared p, and minus 80. Perfect. So this fits. This fits this. Okay, so this is 4. We have to evaluate. If we get the point, we have to evaluate. Partial derivatives are in here, and find max min. So all these are already in this problem. Okay. So how do we start? What is the first step? Can anyone tell us?
First, we have to find P of A and then P of B.
Yes. So I'm going to call this R. So I changed the name. So we want to find RA, and we have to find RP. The reason I changed it to R or B or whatever letter, any letter, maybe R so it doesn't sound like revenue, I changed it into B. Because I really don't like to say PP. And we can go back. The notation is not important. Okay, perfect. So we are differentiating this function with respect to A. First term.
It's 2P.
2P. Second term.
0.
Because we are differentiating with respect to A. What about the third one?
0.
Perfect. We are differentiating with respect to A.
1 over 5.
Yes. Negative 1/5 AP. And this is gone.
0.
Perfect. Now with respect to P. This with respect to P.
2A.
Very good. This with respect to P.
80.
Excellent. This with respect to P.
30P.
Very good. This with respect to P. Right? P prime is 1. So it's negative 1 over 10a squared. And this is 0. Is this okay? This is our first step. Everyone okay with that?
Yes.
Perfect. Sorry. Good. So remember in step 2, we have to create the system. So 2p minus 1 over 5 AP equals 0. And 2a plus 80 minus 30p minus 1 over 10 a squared equals 0. So let's come back to the easiest of the two equations, which is the first one. So since we have a common factor in there, I am going to pull it out. So I have p, and this is 2 minus 1/5 a equals 0, right? So there is p here and there is p here. I pulled it out, and I had 2 minus 1/5 a equals 0. So we have two options here, either p equals or either a equals. P times something is 0 means that p must be
0.
Yes, perfect. So now 2 minus 1/5 equals a. So 2 equals 1/5 a. I move this to the other side, changing its sign, and I have to multiply by 5. So I found that P is 0. I have to go back to the second equation and see what happens when P is 0. This has to wait for a minute. So one option from the first equation is that P equals 0. Okay, so let's see what happens when P is 0 here. This goes away, but I still have 2a plus 80 minus 1/10 a squared equals 0. So when P is 0. So I will multiply both sides by 10 to eliminate fractions. So I have 20a plus 800 minus a squared equals 0. And now I will rearrange, moving everything to one side, like it is here, or multiply both sides by -1, whatever you want to say, but it has to be arranged in descending order. So we have a squared minus 20a minus 800 equals 0. So I'm going to share my screen. Yes, I can use the quadratic formula on this, but I prefer apps, and I go to 9. So this is a quadratic equation, degree 2. So I'm entering 1 is okay. The next one is -20. And the last one, -20. And the last one is 800. -800. Okay, -800. And then I click enter or graph, and I have that A is -20 and A equals 40. Okay. So basically, so what was, let's read again. What is A? A is the amount spending on advertising. So I cannot accept this as a negative value. We didn't spend a negative value on advertising. So P is 0. So remember also how you put in the ordered pair format. So A is 40 and P is 0. This is not acceptable because I cannot say that I spent -20 million on advertisement. Okay, good. Now I have to continue with this. This is one ordered pair. When A is 40, P is 0. But now I also have the other option, A equals 10. So in number 2, I have 10, comma, and I have to determine P. Okay, so from A equals 10, I go back here and replace A by 10 and find P. 2 times 10, 20, plus 80, minus 30P. 10 squared, 100 divided by 10 is 10, but minus. And that equals 0. So now let's see what we have. So this is 100, but minus 10 is 90, and -30p equals -90, so p equals 3. So far, these are the ordered pairs that we came up with. 40, 0, 10, 3. I have to analyze and determine the d-test for both, and then I'll make my conclusion. Okay, so at this point, let me see how am I, no, still okay. I was looking at the time on that other device. Okay, so at this point, I have to find BAA, BPP, and BAP, because the d-test will be BAA times, because that's the first variable, BPP at all these, first for the first one and then the second one, and minus BAP squared. Of course, these are at those ordered pairs. So let's continue with BAA. So this was BA, and we want to differentiate again with A. Nothing. Again with A.
1/5P.
Exactly, -1/5 P. Awesome. So this is it. Now BPP.
-30.
So with respect to P, yes, there is only negative 30. Excellent. And now BA with respect to P. With respect to P, we get 2. And with respect to P, we get negative 1/5 A. Okay, let me also copy here so I can, so it was 40, 0 and 10, 3. So this is number 1 and this is number 2. So the D test for number 1, and this is BAA. So remember, this is A and this is P. So BAA, I don't have any A to plug in, but I have P to plug in, and this is 0. Okay, so at this point, I can stop. Because remember, I did not put that previous lectures yet. So this, whatever that is, this has to be either strictly greater than 0 or strictly less than 0. But this is already 0. So we can disregard this point. So D for point 2. So for point 2 with 10, 3, I plug in just 3. And this will be negative 3/5 times. This is times negative 30 minus. This has to be squared. Let's see what we get. So when A is 10, so 10 divided by 5 is 2. 2 minus 2 is 0. That's okay. That is possible. Now, this product will be positive because a negative times a negative. And this is negative. So what can we conclude about 10, 3? Gives a relative what?
Maximum.
Maximum. Awesome. What is the relative max? Well, is that B of 10, 3. And if you want, now we can write P of 10, 3. Because I didn't want you to get confused with P and another P in there. So back to the problem. Where was it? 220 times 3 plus 80 times 3 minus 15 times 9 minus again 100 divided by 10, so it's 10 minus 10 times 3 and then minus 80. So let's see what we get here. So this is 60 to 40 minus I think it's 135 and minus 30 and minus 80. So this is minus 20, so this is 220. 220 minus 30 is 190. 190 minus 135. Is it 55? Can anyone confirm this?
Yes, I also
I
ended
got
up with
55.
55.
Okay, good. So then I don't have to double check. Good. So that takes care of, and of course, I think antiderivatives are clear because without antiderivatives, we cannot determine indefinite or definite. Okay, so that was a perfect example. Do you think we need an example from the average value of a function?